a quiz on Thursday, but it's not going to be like a normal quiz that we do. Like, I'm going to post the answer keys. Like, you're just going to work through it. You get done with it, and then you turn it in. Okay? So it should be really easy for you to get points. So we are going to start, possibly, okay, right here. And we're just going to hit the ground running. So you're going to actually skip over the warm-up problems. And we are going to look at the inverse function of a cube. So a cube graph is shown on your paper. It's this nice little squiggle. And we are going to be graphing the cube root. So all this chapter is the square roots and cube roots. Now, our table right here, f inverse of the cube root, or I should just say the inverse of x cubed, we're going to take our table and we're going to flip it and fill it out over there. So I'm going to have -8, -2, -1, -1, 0, 0, 1, or sorry, yeah, 1, 1, and then 8, 2. So I'm going to extend that table down. Now, I actually like for you to have 5 points. Okay? And so just like with square roots, so I'm going to make a little connection here. When I'm looking at a square root, I typically had the numbers 0, 1, and 4 showing up. Now those numbers are going to be -8, -1, 0, 1, and 8. Okay? Because those are the numbers that we can take a cube root of very easily. The next number you would actually have to go to for a cube root would be -27 or +27. You don't want to do that. It's not fitting on your graph, obviously. So let's plot these points as well, and then let's get into the domain and range and all that fun stuff. So -8, -2, -1, 1, 0, 0, 1, 1, 8, 2. Is there any number I can't take a cube root of? Nope. We can take a cube root of all of those numbers. There's no imaginary numbers that come out of a cube root.
So cube roots are kind of freaky.
Sure. So -8, it's just saying what number times itself 3 times gives me -8. So -2 times -2 times -2 is -8. That's why it works out. So that's what we got going on. Now, if I look at the domain of my function on the left, my original function, my x cubed, my domain is going to be all real numbers. So I can write that like this, or I could write it as -infinity to +infinity. And my range is going to be the same thing, because this thing goes left and right forever, but it also goes down and up forever. And so you can write it the same way. Now, it's just all real numbers.
Could you put any one of those and get it right?
Yep, either one.
Alright.
Okay. Now, if we flip my domain and range, they're the same, right? So if we flip them, we flip my x's and my y's for my inverse function, I get the same exact thing. So I'm going to tell you right now, if you get the domain and range wrong for a cube root function, I might cry. Because it's always the same thing. It doesn't matter which cube root function you are looking at. Your answer is -infinity to +infinity for both domain and range. There's 2 points, actually 4 points on the test, right there. Boom. Now, you obviously got to know a little bit more than that to pass, but that's not too crazy. All right, x and y intercept, it's the same thing. It's 0, 0. That thing will shift around. You are always going to have an x and y intercept. With the square root graph, we didn't always. With the cube root, we always have an x and y intercept. And this one's also the same, 0, 0. Now, we're going to see that there's a lot of similarities here, but there are some differences. Question? Okay, flip the page.
This is freaky. I don't think I understand this.
Oh, you will. You will. Okay. First thing I'm going to do when I see a cube root, I'm going to answer my domain and range. We're going to cover it up. It's cube root. What's the domain and range? Yep, -infinity to +infinity. Write them out, both of them. And it's always this. It is never infinity to -infinity. It's always -infinity to +infinity. Done. We got 2 points. That was easy. Next thing we do, we got to think about our x's. So just like with a square root, I look at what is inside the root. In this case, only x is inside the root. So I think about the numbers that I want to use. -8, -1, 0, 1, and 8. These are like the perfect numbers that I want to take. Like the 0, 1, and 4 were the perfect numbers for square roots. Since they are just inside the root, there's nothing else in there, I just write them down. Now, I'm going to work through some of these. And then we got a little bit of work to do for some other stuff. So I'm going to look at -8. So I have the cube root of -8 plus 1. What's the cube root of -8?
2.
-2. So I get -2 plus 1.
Yes.
And I get -1. Now, what would we expect to happen to our mother function, which is this function right here? If I have plus 1, what should I expect to happen? Translated up, down, left, or right? Up, 1. Everything should go up 1. So if I know my numbers over here, I actually could just bump them all up by 1, but we're going to just double check. So I'll put -1 right there. Cube root of -1 is -1. And then I go plus 1, and I get 0. What's the cube root of 0? 0. So I get 0 plus 1, and I get 1. How are these numbers changing?
Up by 1.
Just up by 1. Notice what's in front of the cube root. Nothing. So that means there's a 1 there. So they're increasing by 1. If I have the perfect cubes on the other side. I'm going to do these last 2 really quick. I'll put 1 and put the square root or cube root of 8. Cube root of 1 gives me 1. So 1 plus 1, I get 2. And then here I get 2 plus 1, so I get 3. And we plot. So that is our function, and our mother function would have been right here. So every point just got dragged up 1 because of the plus 1 on the outside. X-intercept. What's our x-intercept? Perfect, thank you. -1, 0. And that showed up in our table, so that's nice. Didn't have to do any work. Y-intercept, what is it? 0, 1. Also nice. Showed up in our table. Didn't have to do any work. Questions? Sliding down to the next problem then. Let's talk about this one. What's inside that cube root?
X plus 2.
X plus 2. So I'm going to do kind of what I do with the square roots. I'm going to have like whatever number's in there, so x plus 2. And I'm going to set them equal to the numbers that I want, which in this case is -8, -1, 0, 1, and 8. So how do I solve x plus 2 equals -8? Yeah, minus the 2. So I'm going to take every single number here and subtract 2. So I'll go -2, -2, -2, -2, and -2. So I'm doing that to all of them without writing that over and over again. So this is going to give me a -10. I'll change color so it sticks out more. So I get -10, -3, -2, -1, and 6. And I'm not going to lie, that's kind of common. Like, we're kind of stuck around somewhere around there. Because if I go more than 2, I'm off the graph. Right? So my numbers are actually kind of stuck here. And it makes sense because I should be shifting, right? I go to the left in this case because the 2 is in there. So makes sense that it would be a -2. So you can look at this by translations, or you can look at that by solving. It doesn't matter how you look at it. Just show them both. So, -10. I plug that in. Oops. What do I get? You can go another step. Yeah, I get -2. So I'm going to put -2 right there. Give me the other numbers. Plug them in if you have to, or if you know what they are. So you should have -2, -1, 0. What's my pattern going on?
1 by 1.
By 1. So I can use that pattern. Once I have 3, you can always kind of continue on with that. And that's also, again, assuming that we did our work here to make sure those were the perfect cubes. So we got that. So let's plot all those points. Now, if I only looked at translations, this would make sense because my mother function would be right here. Up one there. Because it's shifted 2 to the left. So you can kind of make that connection. Domain and range, what are we looking at? Perfect. Or that. Same thing, right? X-intercept, what is it?
-2, 0.
Perfect. Y-intercept, what is it?
I don't know.
I don't know. That's fair. How do we find a y-intercept?
0, 0.
Plug 0 on for x. Let's see what happens. Y-intercept. I go ahead and I get y equals the cube root of 0 plus 2. So then I get y equals the cube root of 2. Do we know what the cube root of 2 is?
No.
Nope. So your y-intercept is 0, comma, cube roots of 2. Done. I don't even want the decimal. On the answer keys that we post, we put the decimals there because we kind of laugh at you when you put decimals because we've never shown that in class. So be confident in your answers. I will check them for you if you want to. But that's what we got. Questions?
Homework?
No.
Hey.
Next page.
Hey. Can I go to the bathroom now?
Sure.
I'm gonna let you finish it. Are we gonna have homework?
Possibly.
Okay, then I'm going.
All right. Looking at these problems, we got to start by finding our x's. So your numbers that you're looking at are -8, -1, 0, 1, and 8. What's happening inside the cube root? -2. So -2 shifts us which way, left or right? Shifts us to the right. So it's going to be plus 2 for everything. So plus 2, plus 2, plus 2, plus 2, plus 2. So you could solve it too, right? You could say x minus 2 equals negative 8, x minus 2 equals 2, so on and so forth, or 1, negative 1. So my numbers here are going to be negative 6, 1, 2, 3, and 10. So now I'm going to give you a few minutes to work through those pieces. You got to get used to plugging the numbers in. And you can use your calculator to do that, or you can do it by hand. Either one works. Take a few minutes. Try it.
Harvard, get your x values. Are you doing just like 2 minutes, or do you have to like show?
You can do it.
I just want to show. I think that's what I do.
So I'm going to show one of these, and then I'm going to put the answers up there. So this gives me the cube root of negative 8 plus 3. Well, this right here gives me negative 2 plus 3. So I get 1. And if you plug in the rest of the numbers, you're going to end up getting the 1, then you get 2, 3, 4, 5. So that's what we're looking at there. Plotting all these points. it's going to look something like that. X-intercept, we gotta find. Y-intercept, we gotta find. So nothing's really nice here. So x-intercept, I'm gonna skip. I'm gonna start with the y-intercept because most of the time the y-intercept is easier to find. So my y-intercept here is gonna be 0, comma something, and that something is going to be the cube root of 0 minus 2 plus 3. And then that just leaves me with the cube root of negative 2 plus 3. That's what I actually plug in for my y-intercept. I'm going to make my parenthesis go out a little bit further and write that in. X-intercept. So we plug 0 in for y this time. That's probably also going to have to change a little bit. So we got 0 equals the cube root of x minus 2 plus 3. So you tell me, what's your first step in solving that? Minus 3. Now what? Cube it. So we cube both sides. And this is something that throws people for a loop normally. They cube this and they go, okay, I just got negative 27. That's a big number. That's not showing up on my graph. That's good. It doesn't show up on your graph. Like, we are not going to see it happen on our graph. So this is actually very good. And then we get x minus 2. I add that 2 over to the other side. And our x-intercept is going to be negative 25. That's a pretty common answer, something that is off your graph, because cube roots are not going that fast as you go through this. Questions? The last one is all yours. Try it out. There's a 2 in front, so I'll put an example of something along with that in a moment, but try it out. See what you can get. Figure out the x's. What x's should you use?
Isn't this supposed to be locked?
So, we're subtracting 1, but then every time we're using negative 1, 0. So for those, change it off of that. Here, so it's going to be like this. So you're right here. Right? So this is, so you get negative 4 minus 3. So for your very first point at negative 9, it's going to be negative 7.
Nichols, I don't know if I did this right. You know, someone put one of these through my sunroof. I leave my sunroof open all the time so I forget to close it. And I found one of those like on my passenger seat. There should be one. Nuh-uh. Yeah.
Because you do have a like you say something that -2 plus.
I don't like this game. Down by that B.
Right, because I did -9 plus 1. It's -8.
Nichols, do you remember the song Down by the Bay? You're the one that you win. Back to my home.
No.
I dare not go. And if I do, I might Nichols, no.
Okay, folks. What are the remaining 3 numbers?
Oh my god, I understand it now.
What numbers in front of our cube root? What are these changing by? Well, positive 2, right? Yeah, because they're adding up. Domain? Perfect. If I graph this, it's going to look -9, -7. It's not going to look nice. So it looks something like that. So y-intercept we have, it's 0, -1. X-intercept we have to find. So I'm going to have 0 equals 2 times the cube root of x plus 1 minus 3. So we add this 3 over to both sides. We add the 3 over. And then we are going to divide by this 2. And this fraction doesn't have to be anything crazy. It can be, it doesn't matter. You can type it in your calculator. You can kick out a decimal if you want. Not really always the best option, but that's an option. So this is gone. So what do I do to get rid of the cube root? Cube it. So I'm looking at 27 over 4. Is it x plus 1? Yeah. Oh, yeah, it should be.
Nichols.
So we got 27 over 8. I minus that 1 away. And this 1, remember, is just the same as 8 over 8, right? Like if I want to do my fractions here, I can have 27 over 8 minus 8 divided by 8. And that is going to equal x, which equals, and if you got the decimal, that's fine too. What do we get? 19 over 8. So we're just going to slide up just a little bit and put 19 over 8, comma 0. Questions?
This unit's pretty easy.
All right, really quickly, square root. What's the three numbers that you start with?
0, 1, 4.
0, 1, 4. What are the 5 numbers you start with for a cube root? Perfect. What's the domain for cube roots? All real numbers. What point gives you your domain in range for a square root function? What? Yes, the starting point. The 0, 0 for our mother function. And after that, how that point is adjusted. Okay? You can pack it up today.
That's fine.